In this video, we're going to talk about how to compute the slope of a line. So to begin with, what exactly is slope? The answer to this question is, in sort of the exact answer is, the ratio of the change in y to the change in x. Picture-wise, what are we seeing? Well, we saw in the last chapter that essentially what we're doing is, for every bit we go over, we go up a certain amount, right? And that sort of dictates what my slope is, right? Namely, here, if this was some sort of an x1, then I'd have some sort of a y1 as well, right? x1, comma, y1. Here, at that point. Up here, I could similarly have an x2, comma, y2. But what I notice then is this distance, for every bit that I go over in x1, this would be x1, x2 minus x1 in distance. I also go up in y, so y2 minus y1. In other words, this is how we define the slope, is the ratio of these changes. The change in y, or if you prefer delta y for change, and then this delta. Delta is the triangle symbol here. Delta y, delta x, so delta, is what? So in other words, it's y2 minus y1 over x2 minus x1. An important thing here, though, is that no matter which x1, y1, and x2, y2 you pick for a given line, the slope is unchanging. So it doesn't matter which ones you pick, this ratio always stays the same. In other words, what if you had swapped these and picked them the other side? This would have been the same thing as y1 minus y2 over x1 minus x2. And so as long as you're consistent, make sure the ones and the two stay above like each other, you should be fine and have no problem which order you pick the points in. So now let's have you do an example. Let's find the slope of the line passing through each of the following pairs of points. So for negative 2, 0, and 3, 1, let's go ahead and graph it. It's easier to sort of see it if you graph it. So negative 2, 0 is where? Negative 2, 0 is, you go 2 over and you're at 0, and then 3, 1. 1, 2, 3. So 1, 2, 3, 1. So in other words, we're trying to figure out if we were to draw a line through those points, what would its slope be? Well, that's easy. It's just m equals 3 minus 0 over 1, because 1 and 3 went together. 0, oh, whoops, I made a classic blunder. Y goes on top, right? So m, 1 minus 0 over 3 minus negative 2. So be careful with your signs. Here we have 5 and 1 on top. So 1/5 should be the slope. Well, if you look at this, indeed it actually is. Because if you go up 1, you have to go over 5. This, by the way, so this delta x and delta y over delta x, this is also usually called rise over run. So we have to rise by 1, and then we have to run by 5. 1, 2, 3, 4, 5. Okay. What about over here? Over here we can do a similar thing. Namely, here m would be 2 minus 2 over 2 minus negative 1. 2 minus negative 1 is 3. 2 over 2 minus 2 is 0. So the slope is actually 0. Does that make sense? Well, it does, because they have the same y coordinate. Namely, if you were to try to draw a line between the 2 points, what would you have? You go negative 1 up 2, and then at 2 you go up 2. But you see, if you draw a line through those points, it's just a horizontal line. And we know horizontal lines have slope 0. Right? Good. We know horizontal lines have slope 0. Let's look over at this example. This example, I got these backwards. I think this is supposed to be D and that's supposed to be C. Oh well. Here at D, apparently, we have 0, 4, and 1, negative 1. So if we do the subtraction, what do we get? We get negative 1 minus 4 over 1 minus 0. Again, we just got to be consistent in our points. So we get negative 5 over 1. So m equals negative 5. Does that make sense? Well, think of it as negative 5 over 1 helps because here you have negative 1 comma 1 comma negative 1. So there. And then 0, 4, 1, 2. So at 0, 1, 2, 3, 4. And what have we said here? Well, we've said basically for every 1 unit of run you have, you go down, so you drop down by 5. That's why it's negative, because it would go downward. Here, 3, 4, and 3, 1. Well, here, when we try to do the subtraction, we get 1 minus 4 over 3 minus 3. And we end up with negative 3 over 0. So we have an undefined slope. Well, that makes sense as well, because we saw in the last section, I made a remark that vertical lines have undefined slope. Is this line vertical? Well, of course it is, because it has the same x-coordinates, namely 1, 2, 3. 3, 1 is there. 3, 1, 2, 3, 4 is up here. And that is indeed, the line between them is vertical. So lines have undefined slope. Just to bring that back. And now it's time for you to try an example. So find the slope of the following lines of the line passing through the following pairs of points. On the count of 3, I'll reveal the answers. 1, 2, 3. So there you have the solutions. Again, here, this one's interesting because it actually reduces a fraction. It's 2 over 1, which you can see as I drew the lines. The rest I also drew the lines. Here it's kind of hard to see the line because it's the y-axis. But there you go. So, for more practice in graphing and finding the slope for lines, be sure to see page 31 of the textbook and work numbers 2 and 15 through 42. In our next video, we'll talk more about writing linear equations.